Hello, everyone. This is Amy Brown, Director of Events and Education for Trade Press Media Group and Facilities Net. Thank you for joining us for today's webcast, Integrating a Snow and Ice Melting System into your BACnet BAS Facility. Our presenter today is Eric Balt, Technical Sales Manager for Tekmar Control Systems, a Watt brand. Eric has nearly 25 years of experience in the HVAC control industry and has served as Senior Technical Instructor and Designer focusing on HVAC for the BAS manufacturer. He has managed a substantial controls contracting firm and now works with the IoT smart and connected products. Eric has also served as an ASHRAE chapter president and has held multiple chapter chair positions. Today's learning objectives include discussing the benefits of snow melting at commercial spaces, review key snow melting system designs and financial implications, learn about snow melting control strategies and considerations, and reviewing how to integrate snow melting with a building automation system. Before we get started with today's webcast, I'd like to cover just a few details. We do encourage audience questions throughout the webcast, and to submit your questions, please navigate to the bottom of your screen where you can see the Q&A button and type in your questions. Our presenter will try to answer as many questions as time permits. At the conclusion of today's event, you'll also receive a PDF copy of today's presentation slides. You'll also receive a link to a brief online assessment, and upon successful completion of that assessment, you'll receive your CEU certificate. Today's webcast will also be archived at facilitiesnet.com/webcast. And with that, I'll turn it over to you, Eric.
Great, thank you, Amy. Appreciate the introduction. I'm Eric Balt with Tekmar Controls, and I'll be taking you through this presentation today. As Amy was saying, it's based around BAS systems and snow melting in your commercial applications. And we will start with the first slide here. Just want to introduce the company. Oops, let me back up here. That jumped on me. Okay, just want to introduce the company. We're based in Vernon, British Columbia, Canada, which is north of Seattle. Approximately 110 employees. We're part of the Watts organization. We were purchased by Watts back in 2012. Our background is core products are multi-staging, boilers, snow melting systems, alternate energy, thermostats. We're actually electronics manufacturer facility, and we also manufacture products for different organizations and companies in the marketplace out there as well. One of the key things that we actually really focus on is making sure that we support our customers properly in the field, whether they're the heating, plumbing and heating contractors, the engineers, the field people, even homeowners. We do have a complete tech support team on staff so that you actually can reach us and talk to somebody knowledgeable in our products. So we ensure that we actually maintain and support the marketplace that we have out there as far as our products are concerned. So as Amy was saying earlier, the agenda today is why do we want to do snow melting versus plowing and removal? Looking at snow ice melting examples of some applications, so you guys can, people can take a look and see, how can this actually be done? There is a classification within the ASHRAE organization that would determine how effective your snow melting system is going to operate, and it's going to be basically tied to your cost of operation as well. The more snow melting and preparation we do, of course, the operating costs will be reflective. And we're going to go through some examples of operating costs in a few slides down. We'll also looking at the snow ice melting sequence, like what are the things we are concerned about as far as operating that system properly. It's very easy to turn a system on. The big question is when to turn it off. If you turn it off too late, we end up in a situation where we're wasting a lot of energy and you're going to get higher bills. If we turn it off too early, we end up in a situation where we actually create an ice rink, which is not what we're after. We'll also look at some control strategies, and at the very end, we'll have a question and answer period. And as Amy is saying, if along the way, if you feel that you'd like to ask a question, do use the Q&A, and we will address those as we go through at the end. So why do we want to do snow melting? Well, there's some key factors here. Safety. as far as the especially on sidewalks and entranceways to buildings. People, of course, there's the whole issue of slipping and sliding and falling, and then what that brings. Convenience. We do not need to be out there trying to plow snow at 2 o'clock in the morning so that we are good to go at 5 or 6. Or if it's still snowing at 5 or 6, when do you actually plow? The liability component, as far as your sidewalks and your entranceways on your buildings, you are liable to make sure that those entranceways are clean and not going to slip on them. Your cost of snow removal, if you are doing snow removal versus snow plowing, or it could be a combination of one or both. A lot of times it's just snow plowing and you pile it up, but a lot of applications we do not have room to pile up the snow, so it has to be removed and put somewhere. And then the other issues are the chemical damages concerns. We use salt and sand to ensure that we keep our surfaces safe from slippage. But where does that salt and sand end up at the end of the day? When the snow is melted, the salt and the sand is definitely still there, and it has to be addressed. And of course, with that salt and sand, you're tracking that into your facility, and you're dealing with that within your facility in the entranceway. So your property maintenance is part of that equation when you're doing that situation. So here's an example. This is actually our building in Vernon, British Columbia. It's our entranceway to our building, and we have a snow ice melting system there. It can be snowing at any time, night or day, and we pick that up automatically and bring the slab up to a temperature that actually melts the snow. At the end of the walkway, there's a drain so that we don't create a situation where we actually built up an ice dam down at the bottom, which is important. We don't want to create the situation at the end of the snow melting slab or on the sides of the snow melting slabs where ice could build up and cause an issue. It helps to reduce the liability and potential for lawsuits, as I said earlier. And, there's one average of 11,500 snow melting shovel industries treated each year in the US. It's an ongoing situation, as far as shoveling is concerned, and where do we put it and how do we manage it? I want to show you some applications. I think it's important to understand applications. Here on the left slide, we've actually got a set of stairs, and we've actually snow melted the stairs to ensure that those stairs remain slip-free, no sand, no salt. We're not tracking that into the building, which is a very good positive. In the middle picture, we got brick pavers, which can, if you have a snow plow with blades, you can actually damage those brick pavers, and you're now looking at maintenance on your actual surface after the snow is gone. In that center one too, also we have there's a snow ice sensor actually located there. That's that little blue circular thing there with the brass, and we'll be talking a bit more about that. And then the right-hand side, we've actually got a lodge. It's a ski resort lodge and an area where people can sit outside and eat. So basically with that, we actually snow melt that area to ensure that those areas stay clear of snow for the convenience of what we're trying to accomplish at that location. Property protection, your textured and colored concrete. I mean, there's a fair amount of money that can be spent on your surface going into your building and around your building. Curbs are typically damaged by blades hitting the curbs and basically damaging those curbs, so they have to be addressed. The corrosion issue with your salts, and as I said earlier, salts and chemicals. And people nowadays are becoming more and more aware of what's going on in the environment, and where does that salt and chemical end up, right? So we need to be accountable for that, and we need to understand the usage of those materials for our snow melting situations. So these are the things we're actually looking at and concerned about. Here's the good one. The financial component of lawsuits when it comes to commercial buildings, people slipping and falling, and all of a sudden there's a lawsuit that comes your way. You were responsible. So one of the key things on snow melting systems is we can actually help to reduce the potential for financial lawsuits. Lawsuits are considered your issue with your revenue. Each year in the US, $500 million is spent on defending lawsuits from snow and ice related injuries. And then of course, the cost of the snow removal. So those are the aspects of what you're looking at when you're operating your facility. You may have experienced it already. I know my brother just north where I live here has a snow plowing business, and insurance for his business is a big part of the actual cost of snow removal because he does get the lawsuits coming at him from time to time. I'm going to show you some examples of the actual snow melting systems. I'm just going to walk through them. At a commercial level, on the left-hand side, we have government type facilities. We've got basically a hospital. We've got an entryway into the ER emergency area for the ambulances. We need to keep that area clear of snow 24/7, 365. So it's a very high profile situation. And we ensure that once the temperature outside goes cold enough that we're actually maintaining a temperature above melting 24/7. Once the temperature actually goes up, we actually can turn the system off. So that's part of it. Car washes are kind of unique in the fact that it's more like a de-icing situation where the cars are exiting out of the car wash and you have water dripping off the cars and you got to deal with the water turning to ice. So we actually use snow melting to not allow ice to build up there. On the right-hand side is a helipad, basically same scenario, keep it clean 24/7. Such that when the helicopters do land, there's always a snow ice-free environment for them to land on. Sidewalks, big thing with sidewalks, of course, is when does it snow? It doesn't snow, or it could snow at any time in the day or the evening or the night. So basically sidewalks are a key aspect of making sure they stay clear of snow or ice buildup. And that's the part of a very important aspect of snow melting systems is ensuring that we keep those surfaces clear when it snows. As I said earlier, here's the car wash, a bit closer picture. On the left-hand side, the bottom picture is actually the egress of the snow melting of the car wash itself. And basically this was first thing in the morning before they actually opened up the car wash. I went down there, I took some pictures of the car wash before the car wash actually opened up. So you can see on the exit side that they're actually already melting, getting ready for that situation. This one's a 10,000 square foot snow melting system. It's basically a facility for warehousing. It has incoming and outgoing trucks. Basically, we keep the surface area around the bays clear such that we don't have any issues with trying to plow or maintain a clear area under any condition at any time during the winter months. And there's no issue to have plow vehicles in there at the same time because we've got the snow melting taking place in that environment. Ski resort up in the, I believe this is up in the western US, up in the mountains there in, let's see, Utah, potentially over in Colorado. I'm not exactly sure which location, but basically there was a lot of snow melting. The amount of snow that they're getting per year, trying to keep up with it, they decided to put the snow melting system in to keep the critical areas clear no matter when it snows, that we'll have a situation where they actually have snow-free area. So this one's 100,000 square feet. The heat source was from, as you can see here in the right-hand picture, we have some boilers actually generating the hot water, and we're pumping out into the piping, which is laid into the subsurface of the areas that people are standing on. And operation-wise, when do we want to actually put heat out to the slab? Is it a 24/7, 365 situation, or can we actually bring it down into a different mode of operation to try to save some energy? And I'll be talking about that in the next few slides. Commercial application here in, it's actually, this installation is actually in Montreal, Canada. It's 350,000 square feet of snow melting. Basically, our heat source, our heating plant was not large enough to do all the area at one time. So it was decided to actually zone the snow melting areas. So one area gets snow melted first. Once it's completed, it moves on to the next area. And once it's completed, it moves on to the third area. At any time, if they're in a snow melting process where, let's say, zone 1 has actually been melted and zone 2 and zone 3 are not melted, and then it starts to snow again, what will happen is that we'll go back to zone 1 and remelt that zone before moving on to zone 2 and zone 3. So we keep track of where we are in the snow melting process to ensure at the end of the day that all zones are properly melted and clear of snow once the snow vents have stopped on us. Types of heating sources for your snow melting system, as you can see on the left-hand side there. We have electric mats and cables. Basically, electrical is good for atypically smaller areas because of the cost to operate. You'll see them used a lot in your staircases and your entryways if you just got a small area to deal with. On the right-hand side is embedded in the concrete is hydronic tubing. And in the tubing, we'll be running glycol solution to heat the slab and basically melt the snow that sits on top of the slab when it is snowing from that perspective. Typically, the hydronic system on the right will be a larger square footage. The operating costs are lower than on the electrical side, and that's what you'll see of the sort of two main methods to do snow melting in the marketplace. The advantages on the electrical system, typically lower installation costs. It's easier to install electrical system electrical heating into your slab than your hydronic. You typically have quicker warm-up times. The amount of energy implemented onto the slab is instantaneous as soon as you turn the power on. So you will see typically a faster response. And I said earlier, it's ideal for those smaller areas because of the item below where it talks about the cost of operating. So typically you're not going to see big 10,000 or 20,000 square feet of electrical. You're going to see smaller areas around walkways and entranceways going electrical. And then you've also got to consider on your building, if it's electrical, how much power is available for you to use at any given time, right? Do you have the services and capability to actually deliver the power required to do the electrical snow melting? On the hydronic side, as I said earlier, generally lower operating costs. We typically have choice of fuel, whether it's natural gas or oil or whatever method of energy we can look at. Of course, everybody's looking at decarbonization nowadays and the heat pump technology. There's a lot of talk in that marketplace, and there's a lot of change coming at us. So we're going to be taking a really serious look at what are heat sources, and it could be a combination of different types of heat sources based on their operating conditions and efficiencies. I think that is probably the direction that we'll end up going, where you'll see multiple different heat sources generating the heat for the snow melting to get our CO2 footprint at a lower level. Some of the disadvantages, the installation costs of hydronic systems are typically higher than what you'd see in the electrical side, and some maintenance may be required, though the maintenance on once it's installed is basically your maintenance of your actual slab itself, whether you're using concrete or asphalt or brick pavers or whatever that material is. It's the maintenance component of that. Once the piping is in, you typically don't have to be concerned about the pipe, and the life cycle of the pipe is based on the manufacturer, how long they warranty the product, right? Okay, let's take a look at some numbers here. You have to forgive us here. We focused in on Colorado Springs. It has almost 29 snowfall events per year. And a snowfall event can be, 1 to 2 inches up to 2 to 4 feet, depending on, where you are and how often it occurs. 29 snow events is a very high number. I don't know, you'd have to take a look in your area. I know that ASHRAE has standards to tell you exactly kind of how many snow events you should be experiencing on a yearly basis. It does vary year to year, as your snow plowing bills will probably vary from year to year. So you can go back and take a look, from your company you're working with right now that's doing your snow plowing for you. Typically, are they charging you by the event? Take a look at their bills and see if you can get some information out there. How often are you actually seeing them come in to plow snow? Here we have an example of 29 events in Colorado Springs in Colorado, 5,000 square feet. When we're using snow melting systems with natural gas, we were looking at $2,200 per year operating cost, and the equivalent based on mechanical snow removal at a $200 per event was $5,700. Also, this does not take in consideration financial risks. Think about the financial risk and the other items I just talked about as far as the sanding, the salting, and all the rest of it that goes with the removal of by using mechanical snow removal. Some of the things you need to kind of keep in the back of your mind. So here's a bit more detail about this. So snowfall hours per year. So there are 160, 159 hours of snowfall event hours in Colorado Springs, 23 events, whatever it was. We were looking at the actual amount of, on the right-hand side, the left-hand circle, the circle on the right-hand side, 124 is the number we're looking at. We call it a snow-free area ratio. It's the amount of snow and how quickly you want to melt that snow. So we take a look at the BTU per square foot. And you can calculate BTU per square foot into actual energy costs, whether it be electrical or natural gas or whatever your energy source is. Typical snow melting slabs will be designed between 100 and 150 BTU. Contractors out there and engineers have the tools to do the calculations to come up with the proper numbers and sizing so that we can meet the requirements of your snow melting system. And when you're looking at snow melting systems, you kind of say, okay, how quickly, how much, how long? Those are the questions you're going to be asking, right? Is it acceptable once it starts snowing that the snow doesn't start to melt within like a 3-hour period, or should it be melting as soon as the snow is actually landing on the actual sensor and on the slab? Those are design criteria you need to really consider when looking at a snow melting system. And the consultants and the mechanicals out there, plumbing, heating contractors, that have been doing these systems understand, and that can be a discussion within those professional people to give you the design criteria you're looking for. How do you want it to respond? So here we take 159 hours times the energy per square foot times the square foot times the energy usage. So there's 160 million BTU per square feet. So 177 million BTUs per square feet per year for the 5,000 square feet. That can be converted to actual cost. This is what we're doing here. And here's where those numbers where I showed you earlier. Dollar per million BTU on natural gas, $7.5 per million BTU, and electricity, $29 per MBTU. You can see quite a difference in operating costs between the electrical and the natural gas. So that's why I was alluding to earlier that, on the smaller installations, it's very feasible to take a look at electrical if your service is provided. If you do not have a heating source like a hot water boiler plant or a source to heat from. And then on your larger systems, you look at your natural gas boiler plant as your more economical method to actually melt snow. So here's a rule of thumb, 25 to 50 cents per year to basically give you some idea where you're going to be at as far as your costs to actually do your snow melting from that perspective. Okay. So as you can see on the right-hand side here, rule of thumb, is be mindful rule of thumbs are rule of thumbs, right? They just give you an average from the perspective of, costs are concerned. So based on how we're going to operate it, it's going to have a big impact on your operating costs, whether it's going to be an idling system or if it's going to be an actually full idle or just off on, depending on how we actually do it. Okay, let's move to the next one. Did I skip one there? I did skip one there. Let me back up. Okay, so here's the situation where we have a slab that's idling. means that the temperature of the slab is below freezing, is just a little bit below freezing. Once this snow ice detector picks up snow, we'll actually bring up to a melting temperature. And you can see the operating cost there when you actually do an idling melting system. So it actually is changes its picture for sure, but it depends on, from your perspective, how important is it to have that slab up to a melting situation when the snow does start to come down. Key things too, and this goes back to consultants and your mechanicals that I'm designing the system. It takes a lot less energy to turn snow into water than it takes to turn water into vapor. So what we're looking to do on your snow melting system is it's a huge energy waste to sit there and try to evaporate the moisture off your slab. What you're really wanting to do when you're designing the slab is to melt the water and drain the water. And that has a huge impact on operating costs. And I would say most all snow ice systems are designed for the water to be drained, not to be evaporated. If you're looking at evaporation, you're looking at as you can see here, 7 times increase in energy requirement to actually turn that water into evaporate. So we don't really want to go that route. The drains will be needed to be heated so that we don't create a situation where the water freezes in the drain and creates a big ice dam. And from that perspective, yeah, part of the equation is when we're doing the snow ice melting system, we're going to heat our drains, we're going to melt the snow, turn it into moisture, and then we're actually going to drain it into the drains and run it off. Realizing that we've put no sand or salt on the surface at this point, so the water is basically as pure as it can be going into the drain. So we should have no environmental impact as far as pollutions into the water when we do snow melting. We're going to take a look at the sequence of operation for snow melting. What are the sequences? And I'm going to go through them at a kind of a fairly quick pace, but I want to step through them so you understand how we're going to operate this system effectively. What our goal here is to make sure the surface of the temperature is maintained at a temperature that is above melting. In this example, we've got 35 degrees as the surface temperature. And what happens typically as the outdoor air temperature gets colder, we'll need to put more heat into the slab to maintain a surface temperature of 35. So as you see in this example here, the outdoor temperature is 20 degrees Fahrenheit. We're actually putting about 46 degree slab temperature to maintain a surface temperature of 35 degrees. That is a crucial part of snow melting systems, and that's part of our control strategies to ensure that our surface temperature always remains above melting when we're in melt mode, no matter what the outdoor air temperature is. So as you can see here, as it gets colder outside, we're going to put more energy into the slab to maintain that slab temperature that you see at 35 degrees. In the sensor itself, what we're looking for is the ability to detect the moisture under any condition, if the and measure the outdoor air temperature, and also if the outdoor air temperature is low enough, we are going to be in a situation where we can actually detect and know that it's time to do snow melting. So in the sensor on the left-hand side, there is rings in there. The temperature on the surface of that sensor is always maintained above the melting temperature. As soon as the melting temperature, as soon as ice or snow lands on the sensor, what will happen, the sensor itself will then track the actual temperature of the slab, and the evaporation rate, melting rate of the snow or ice on the actual sensor will be equivalent to the slab. And once we detect no more moisture on the sensor, it should be respectively the same on the slab, and we should be able to turn the slab off without creating an ice rink. So the slab should be dry when the sensor is dry. That's the sequence of the operation for that snow ice sensor. And fundamentally, this is the aspect of it's easy to turn it on, but it's very hard to know when to turn it off. And that's one of the key factors on that snow ice sensor, is the ability to know when to turn it off. Some of the key operating points, we have these 5 different set points that we should really be cognitive of. And I'm going to step through them one at a time so you understand what they are. Warm weather shutdown, cold weather cutoff, melting temperature, storm, and idling. Warm weather shutdown. We do not need to try to melt snow when the temperature outside is above 32 degrees. Unless you live around the Great Lakes area, where we see situations where the outdoor temperature can be warmer than 32 and it still snows. So just be cognitive of your area. You may find that around the Great Lakes, for example, we might have to have a warm weather shutdown at 40 or 42 degrees because we're seeing snow at 38 degrees Fahrenheit. That's one of the key things about warm weather shutdown. It also saves energy, so we don't waste energy trying to heat a slab when there is no situation where the slab will have snow on it. So we have a warm weather shutdown setting, and we put that into the system. The next scenario is when the outdoor air temperature gets cold enough that you can no longer melt the snow on the actual surface of the slab. Basically, the energy required to melt that is beyond the capability of your heat source. And at that temperature, when it's colder outside, you typically have very cold snow, very sticky. It's not slippery. So what we'll do is when we hit a temperature, let's say 20 degrees Fahrenheit, as I've given you an example here, you can set to whatever you want, or maybe minus 20 degrees Fahrenheit, whatever you so choose. At that temperature, we will no longer operate the slab or try to actually melt snow on the slab. So if the temperature, let's say we had it set to minus 20 degrees Fahrenheit, when it got to minus 21 degrees Fahrenheit, we'd actually turn the slab right off, not to try to do any snow melting on that slab. What happens though if you're doing snow melting on the slab and the outdoor temperature goes below your cold weather cutoff? We have a mode called melt pending. We'll actually turn the snow melting system off, and we will wait until the actual temperature outside goes above that cold weather cutoff temperature and restore and begin the snow melting process so that we can actually bring the temperature back up, melt the snow that's on the slab, and turn it off, ensuring that we have a clear slab once the temperature is warmed up. We call that melt pending mode of operation. Idling. Why do you want to idle a slab? If you're idling a slab, of course, you're expending energy continuously, but depending on your application, you may want to make sure that if the outdoor, once it starts to snow out there, that the time it takes to actually get the snow melting is very, very quick. So I could be idling the slab at, let's say, 30 degrees Fahrenheit. As soon as as soon as it starts snowing outside, the snow ice sensor picks it up, and then we're going to elevate the surface temperature to 35 degrees at 36 degrees Fahrenheit and melt the snow. The pickup time is very fast. It's what is indicated in the slide deck. We don't have to wait for a long time period for that slab to get up to temperature. Of course, the downside of that is the energy expelled when you're actually idling the slab continuously during the winter condition. But you may have situations where you need to do that. Melt set point. That is the surface temperature that we want to obtain to be able to melt the snow on the actual surface. Minimum, 30, definitely above 32 degrees. Typically, we see settings like in this example, 36 degrees as the surface temperature for melting snow that accumulates on the slab. We could set it higher or we could set it lower. And depending on your conditions, you may see that you need to have a bit of a higher or a bit of a lower melt set point. Just monitoring how the system is operating will determine, how high to set that melting set point. This is a very important one. It's a new technology, part of the IoT world and weather services. And I think it's a great one to consider when you're looking at a snow melting system. It's called Storm Alert. So if you have an internet connection to a weather service, they can basically let you know when a storm has been predicted, and they'll send out notification to us that there is a storm storm alert out there. And what we can do is we can take the slab, which is off, snow melting system is off, and bring it up to a idling or a melting set point temperature. So there's energy savings to be realized if we use a storm alert connection to a weather provider, and we will see lower energy usage bills. And basically, if we have it, bring it up to an idling temperature, and what happens, let's say the alert goes out, but we do not have a snow event, we will, after time period, automatically turn the slab back off. So we're not wasting energy trying to get prepared for something that's not going to happen. If it snows, that's great, because now we have our pickup time is very good because our slab is already warm and we're melting snow very quickly from that perspective. So consider that when you look at snow melting systems and integrating into your building. You definitely want to look at your weather service as a storm alert function. Different control methods. We have to take a look at what you have in your facilities right now. We have situations where we have facilities that have building automation systems in there, and we have facilities that do not have building automation systems in the building. Right now, we're going to take a look at here. This example is where we have a building automation system in your building, typical Class A, Class B type building. And we actually want to integrate it into your BAS system. There's two methods of integration here. We call the one on the left configurable controller, where we're actually going to control all the equipment to run your snow melting system, your mechanical equipment, your pumps, your valves, your mixing devices, etc. And then we're going to interconnect to the BAS system, where they will monitor and make adjustments and report. If they so choose to do that, they can report out operating concerns or issues and let you know what's going on with your snow melting system. They can also report back amount of hours of usage, and if they know their heat source and the amount of energy being consumed, they can give you information about what's going on with the consumption of your snow melting system as well. The picture on the right is basically an interface device that to a BAS system. So the BAS system, the building automation system, will basically take our signaling, and we're going to give them a bunch of information as to how to operate the slab, and they will actually run it with their programmable controller. So it's integrated into their system, and they're using their equipment to run the mechanical gear. They're going to run the pumps and the valves and et cetera things. On the left-hand side, basically, if you got a service agreement with a mechanical contractor, the mechanical contractor will have the ability to make adjustments locally with that control we're showing on the left-hand side. On the right-hand side, atypically, you're going to have a service agreement with your control contractor, and the control contractor will be the one that will be interacting with you on maintaining and adjusting and operating your snow melting system. Sometimes you'll get, mechanical contractor will sub to control contractor, and then we run the situation where the mechanical has a problem, but the control contractor is late to show, and then where's the service? And you've got a service contract. You expect a service when things are not working properly. So just take a look at that when you're looking at how are you going to put your system together and who's responsible for actually maintaining and servicing the snow melting system on your facility. Let me back up, jump this right here. Okay, this is a mechanical diagram. Well, it was a mechanical diagram. We'll go back. On the left-hand side is our heat source. In this example, we're showing a condensing boiler with a pump, and we're having flow through that heat source. And then the right-hand side is our actual slab, the curly little tubes supposed to represent the radiant tubes there. We have pumps to pump the fluid around between the two systems. And the key thing here is on a mechanical design is that we do not want to damage either of these devices. We don't want to damage the boiler on the left or the slab on the right. So we have sensors to monitor the temperatures, and we have pumps to pump the flow through, and we have a mixing valve there. That's the three little devices right here, three little ports. And those ports will allow us to mix the temperature to protect our boiler and also protect our slab as well. This is the configurable controller. All of this mechanical equipment is being controlled by the controller itself. The mechanical contractor would have the ability to get in there and adjust, provided they have technical people to do that. They do not need to call in the controls contractor. Notice on the left-hand side, or sorry, the right-hand side, there's two snow ice sensors. The reason we did that is because where should those sensors be located? You got to take a look at your facility. You got to look at your wind directions. You got to be concerned about where can you have drifting occurring, and you're trying to locate those snow ice sensors where we get accumulations of snow could pile up on our slab itself. It's interesting, we see situations where people put the snow ice sensors underneath overhangs, or they end up underneath a dumpster, And in both those situations, basically, you basically have disabled the functionality of the snow ice sensor. So when the design process taking place, make sure your sensor location is proper for the application, and it's not going to be hindered by things that happen later on the actual usage of the slab. Now, what can be done, you can also put extra sockets in, so you can actually mount the sockets in the slab before the concrete goes in or the pavement goes down, and leave them empty. And if you so choose later that you want to move it to a different location, the snow ice sensor can be moved from location A to location B. So in this diagram, we're seeing both sensors there. Either one can start the snow melting process, and then away it'll go. The heating source will be operational, and we'll start to inject the glycol solution into the slab and heat the slab up, bring it up to temperature, melt it. Once the moisture has been, no more moisture detected on the snow ice sensors, we know it's time to be able to turn that snow melting system off, save ourselves the energy that we're looking for. Notice there's an outdoor sensor there, so we know whether we should be in warm weather shutdown or cold weather cutoff. So those outdoor temperatures are part of the equation. I think I did it again. Yes, I did. Sorry about that. Here we have a situation where we're actually tying directly into the BAS system. So on the right-hand side would be your BA system. They could be doing alarming, they could be energy notification to you. They can adjust the set points. We feed the BAS system the appropriate information to run the snow ice sensor properly, and also to run the slab properly. Targets for temperatures, and from there, it is the BAS system control itself that actually runs the mechanical equipment. We are just an interface to the BAS system in this configuration. And we look at the interface device itself. In BACnet testing lab, it's been PTL certified, which means that when we actually go to install the system, the contractors out there, controls contractors, know that this system has got certification, and integration to the system will be very easy to implement because they'll understand and know that the system actually communicates properly with the existing BACnet products in your building, provided you have BACnet products in your building. But typically this is what we're seeing in the marketplace nowadays. So this is just some of the devices, things we're looking for, making sure you get certified products and communication, setting it up. Here's the exact opposite what I showed you earlier. Instead of us controlling the equipment, the BAS system is controlling all the mechanical equipment. So they're controlling all the inputs and outputs, the pumps, the mixing valves, the boilers, and the heat source, and the snow melting slab. We're just interfacing to the BAS system. So we're telling the BAS system when to operate, how to operate, and then the BAS system is actually doing the actual operation of all the mechanical equipment in the snow melting system. Just a different approach. Typically, when this happens this way, you're going to see your control contractors a lot more integrated into the snow melting system is the strategy going this route. As I said earlier, zoning of systems, when you have your heat source and you may find that you do not have enough capacity, or your heat source, your boiler plant is used for other applications, you may find it's more advantageous to zone your snow melting system instead of trying to do it all in one big zone. Here we have 2 zones, actually as many zones as you want. We could have 2, 3, 4, 5 zones just on your design. And that's part of your equation when you're actually designing your snow melting system. Like, are we going to try to do it one go, or can we zone it out? Just like I showed you earlier with that commercial snow melting system in Montreal, where it was zoned. I think there's 2 or 3 zones in Montreal on that snow melting system. So there's the example of how it actually be integrated. We have sensors and an interface to each zone to the BAS system, and away we go. So we have flexibility in design. And here's the actual physical implementation. We've got a heat source, we've got a heat exchanger, so we're not actually glycoling the whole system all the way up, maybe high glycol percentage on the right-hand side, lower on the left, or very low on the left. So we're not having to run that high glycol solution through the heat source, which basically the heat transfer equations, of course, it's best to keep your high glycol solution on the right-hand side in your snow melting systems. I'm kind of an advocate for the heat exchanger because it does isolate the heat source from the slab. And here we have two slabs, two sensors integrating back to the BAS system. So as shown in the previous example, this is how it be mechanically put together. If you have access to steam, district steam, or a plant, energy plant, here's this example showing a steam valve with a steam heat exchanger, and we're using the steam to actually melt snow. The key aspect, of course, here is steam has got a tremendous amount of energy in it. So we have to make sure our control strategy is good to ensure that we don't overheat the slab as we bring that slab up from that perspective. So we're integrating the steam as our heat source and going to melt snow with steam as in this example. Well, 10:45. This is the end of the presentation. I would like to open it up for the questions and answers at this time, if there is any.
Yeah, thank you very much, Eric.
Okay.
We do have a few questions from our audience members. Eric, going back to some of the stats you were giving in your presentation, where did you get the information for the snowfall per hours per year?
Okay, so that information came out of the ash rate documentation. Specifically, there is the manuals. I've got reference to that. I'll have to actually send that over to you, actually where it came out of the ash rate documentation. But it is documented, and I'll get that information over to you on that question.
Perfect. Thank
And
you.
it's right across, right across the U.S. and in Canada, mostly U.S. data and Canadian data regionally, and then that's important because you need to understand that as far as how you design your system. What are you looking at for snow, right?
Perfect.
Yeah.
Eric, can you talk about some of the reports or alerts that you're able to get from this system? You talked about the cold weather cutoff. Does it alert you once that happens, or does it alert a team member once that happens?
I think the key thing here is if it's integrated into the BAS system, it can be part of the specification when you're actually, what do you want to do with the BAS system? Because the BAS system can report back a lot of information to you. Mm-hmm. So I would say if you're looking for some key fundamental things, number one, energy consumption, like when does this thing operating? When is it on? When is it off? And how much energy it consumes, right? I would be actually documenting that and having the BAS system report back that information, whether it's through their interface or whether it's through a spreadsheet or whatever method they can get you that information. But they can put that information together for you from the BAS perspective. From the perspective, and I'm showing commercial jobs here. So both of those solution sets, whether it was a configurable controller or from the BAS system can actually generate a lot of that data for you. You just have to ask them to put it together for you so you know what you're looking at, because that's going to be part of your reporting out most likely if you're looking at energy consumption. Everybody's into the environment now, energy consumption reports, understanding where we're using the energy, how we're using the energy, right? So that's the way I would approach it.
Perfect.
Yeah.
Can you talk a little bit about installation of a snow and ice melting system? What's kind of involved? How long does it take? Things like that.
I think there's two aspects to that. That's on new buildings and retrofit. Okay. On the new buildings, part of the process, of course, will be in the design process. So the documents will be created, the drawing sets will be done, the layout of the piping, who's involved with actually putting the system in. We've got general contractors, we've got mechanical contractors, we've got plumbing, heating contractors. And then we also have the electrical component to it and the controls company, if there's a controls company. So all those parties are engaged in actually installing the snow melting system. Typically, the pads going in and out of facilities are done kind of at the end of the process, not at the beginning of the process. So, when you look at that, you probably will see the snow melting systems atypically being done at the end of the build cycle, not so much at the beginning of the build cycle. So I think it's just an issue of coordination. Now that's on new installations. On retrofit, you got to take a look at what do you have to work with. If you got walkways and you don't have any piping or electrical cable in there and it's concrete and you want to put snow melting in there, of course, you're going to have to deal with the concrete that's there, which means basically remove it, put the cables in or the piping in, and then re-pour the concrete. So those costs for you are to be considered? And then do you have a heat source? Can you actually get the heat required to do the melting, whether it's electrical or hydronic, right?
Perfect.
Okay.
Eric, can you talk about some of the advantages and benefits of a configurable snow and ice melting control versus snow and ice sensor interface?
When I look at it, the configurable, I look at my service side. Like as a facility manager, I'm looking at who's servicing the building, right? If I have service agreement with the mechanical contractor on the mechanical stuff, and he has the skill set, the people set to be able to get in there and work with a configurable controller, that's from my perspective, that is more helpful to the mechanical contractor, right? If you have a great working relationship with the controls contractor in your building, a service contract, then basically you go that route, right? So I think what it is, you kind of look at who you're working with as far as service providers, and then determine, which way is the best solution set based on the companies I'm working with.
Perfect.
Yeah.
Another question, Eric, on what is the preventable annual maintenance on a system like this?
Good question. From the perspective of the mechanical on the slab itself, it's just, the slab surface, whatever that material is, however you look for the costing on that. The snow ice sensor is very versatile. Like we've had many of those in for many years. The only issue we have is every now and then you got to clean them. Please don't use a wire brush. Use a hard bristle plastic brush, because the wire brush can leave wire stuff behind. You just have to clean the surface off. That's about it for the snow ice sensor, right? And that end of it, and the rest, of course, goes back to your mechanical equipment in your plant, and that you will probably budget out accordingly on life cycle of that equipment.
Perfect. We have another question regarding, you kind of talked about this a few times, Eric, but can you kind of identify the best places within a commercial building where to use snow and ice melt technology?
Best places on a commercial building, typically rampways. If you've got a multi-use type building where there's commercial and residential, a high rise is example. A lot of times if you don't have snow melting on those rampways and they go down, and then the people go down and crash into the doors, an example. I think stairwells and walkways, entryways are key areas. The reason being is because A, of reliability, and B, because of tracking materials into your actual building. I think those are the key areas I'd be looking at as far as snow melting systems are concerned in my commercial building.
Perfect. And any geographical restrictions regarding snow and ice melt?
Not that I'm aware of. Okay, geographically, now where it comes into play right now is there's a huge movement out there, of course, to decarbonize, right? And we're seeing different parts of the U.S., moving away from gas and then going to electric heat pumps. So the biggest thing that we're seeing right now is, okay, the heat source, can we deliver enough heat based on the requirement for the slab? And there may be some local authorities that frown on this as a high energy, but we're going to generate some reports in the next time period to take a serious look at, okay, what's the cost of melting snow with gas, for example, and CO2 versus snow plow with a truck and hauling it away, and salt and sand and all the other environmental impacts of doing that, right? So we need to get we've had some studies in the past, but now we want to get more detailed into that one.
Perfect.
Yeah.
And you've talked about, a few of the either boiler or steam. We have an audience member who's wondering if there's any method of capturing wasted heat in data centers from some of their crack units to use as a heat source, or any alternative heat source options.
Yeah, that's a prime example of another heat source coming at us, right? If you got that heat, you can actually use during the snow melt event, or if you can capture it, a thermal battery of some sort. And I've seen a lot more of that starting to take place on design, where they actually want to capture heat that can be used at a later date. That's the interesting time we're in right now. We're all looking at how do we actually do a better job of, using our heat and energy for what we're doing in our facilities at this time.
Perfect. Yep. We have another question from an audience member on the best way to get first cost budgets. They're typically asked to provide a preliminary first cost budget, only knowing the area to be served. Sorry.
Yeah, I would say probably if you're in that area, a consultant would be probably the best solution set for that. Somebody that's actually a consultant has actually done snow melting systems. Don't engage people that haven't, because they will probably start just from square one. But they're out there, and if you engage them and you can give them some parameters, they can come back with you some budget numbers. Basically, is the way I'd look at it.
Perfect. We're almost at our time. We'll give another second if anyone has any remaining questions for Eric. But Eric, thank you again for this great information and this great presentation. Any final thoughts you'd like to share with our audience?
Yeah, I just for us, we've been in this industry, snow melting. Most of our snow melting has been into high-end residential. We do a lot of driveways and stuff, and I look at it as an opportunity for us to really help to ensure that we reduce, issues with liability. We reduce the issue of pollutants into the water, the things that we're trying to, make life a bit better. And the convenience of the snow melting systems are once you've had one in, you're just like, wow, how come I didn't do that a long time ago, right? So I think that's kind of the takeaway for me, from my perspective, on this whole snow melting world for us.
Perfect. Well, thank you again, Eric, for being with us today and providing great information, and Tekmar for sponsoring this webcast. Just a reminder, you will get a copy of today's slides and a link to take a CEU assessment so you can earn continuing education credits for participating in today's event. We hope to see you at a future FacilitiesNet webcast in the near future. Thanks, everyone. Have a great day.
Thank you all. Take care. Bye-bye.